Hello, my name is Mariam. I'm a student at Newcastle University and I'm studying Master of Science in Wireless Embedded Systems. And today I'm going to present my project, which is Smart Car Parking Embedded System. The objective of the project is to create a car parking embedded system based on machine-to-machine and Internet of Things by using the IR sensors and connecting 3 Raspberry Pis. This low-level program is used to read these 2 sensors that are connected to this Raspberry Pi. This Raspberry Pi also have the same program to read the 2 sensors in it. Both Raspberry Pis are piped to the main Raspberry Pi here, which has the main program. The main program reads a 2D dynamically allocated array. In my project, I have used a matrix that consists of 5 by 4, and I have also used these numbers to represent this matrix. For example, number 2 is the path for the car which can drive, and number 1 represents the sensors which are presenting the parking slots, and number 9 presents the wall or the boundary where the car cannot pass. To make it more easier, this is what I'm trying to achieve in the map. I have used an IR sensor that presents a parking slot. If the IR sensor was 1, this means the parking is empty. If the IR sensor is 0, this means there is a car parked, which we can see also on here. So right now we have the matrix that can show the IR sensors which represent the parking slot, and the IR sensor present the parking if it's empty or full. Another feature is to create a parking routes for the user and to direct the user to each parking desired. For example, those arrows that are colored presents each routes for the map. Another array was created that has numbers, and each numbers presents the routes. Those numbers came from adding the routes from the previous matrix. For example, if I want to reach the first parking, I will add 2 plus 2 plus 2, which equals to 6, and so on. This diagram explains the network that was created for the project. 2 LAN networks are created for the 3 devices. Now, this step is for the pipeline. So right now I'm pipelining the IR sensors that you see here in this device and this device to be read or piped for this device. And when I run the program, this will be shown. So this is the map based on the numbers, and now the testing will be done for each IR sensor. Let's check the first sensor, for example. When the car parks, the 1 becomes to 0, which means the parking is occupied. Now let's test this parking slot. For example, the car will be coming from here, and if this is empty, the car will park in here. This is now occupied, and this is also shown on the map, which is the 0. Now this is the second feature, which is the direction requested by the driver. For example, if I run the program, this will be asked for the driver. Now this is the second feature, which will be asked for the user to enter the route that is needed for any parking. Let's say I want to enter 6 for parking 1. This will be the direction for parking 1. And thank brief explanation for the project based on the OSI model. Layer 1, which is the devices that I have used, the IR sensors and the Raspberry Pi. Layer 2, which is the switch, or the MAC layer. Layer 3, which is the step to create the IPs for those devices, and the LAN. Layer 4 is based on the TCP IP and port 22 for the secure shell. Layer 5 and 6, which is the session layer and presentation layer. The session layer and presentation layer is presented by the secure shell, where it can make two channels connect to each other, and the information that is transferred between the devices are transferred securely. We have layer 7, which is the application layer, the whole application program that you have seen. Thank you for watching the video, and I hope you enjoyed the project.